So we have a question here. What's up, everybody? How you doing, man? So the rate of change. So this is more of the rate of change, and it's more application of calculus. Let's see how we can solve the question. They say the total area S, the total surface area S means the area of a cone. This is a cone here. This is how the cone look like. So the total surface area of where the base radius r means the radius of a cone. The base radius means in the cone there's a circle here. So the base radius r is perpendicular to the height. Means this red is perpendicular to the height. Means they make angle 90 degrees. But now that surface area is given by r squared plus pi r square root of r squared plus height. If each r and height increase that means both r and height increase at the same rate, which is 2 millimeters per second. Alright, so we are given, so I'm going to write this. So we are given the base what? The base radius, which is same for both. Okay, so the same. We given d the r if each r and height increase at the rate of. So d r means radius. But when you say anything with a rate, if somebody say a rate of anything means you take whatever you have divided by time. See, change of whatever you have divided by time. So if each r and height increase at the rate, so let's start with r over t increase at the rate of 2 millimeters per second. You see, distance over time, that's what they give you here. Millimeter over second means dt over d. Distance over radius over time. Now we come here, and h also same. So dh dt also have the same rate, 2 millimeters per second. Find the rate at which surface area. Okay, so now they want us to find the surface area, but the rate means must be surface area with time. So that's very easy, man. When r equal to 40, so they give us r equal to 40 and height equal to 50. So now this is the formula we're gonna use. But how do we know the formula? Let me show how the formula comes about. So we want to find the surface area, the time equal. Okay, so surface area and time. But how did I get this from the formula? Surface area with time. But now look at the right hand side of your formula. What do you have? You have a radius and height. Pi is a constant, so don't worry about it. Pi is a constant because pi is 3.14. So I'm not going to involve in the formula. So my word is going to be only radius and height. So here I'm going to say look, surface area and time means at the end of the day, whatever you're going to write here, it must be surface area of time. So you're going to say the surface area. You know what I'm saying? The surface area means you must differentiate r with s. So surface area with radius. Okay, and then here I'm going to show you how the formula comes, and here is going to be d surface area again with what? With height, because it was with radius, and which other letter we have? Height. Okay, so these cannot give you this, so we're going to say okay, so now here take this r, write the same thing here on top, changing r, and here changing t, which you have r t. Now you do the same thing here, right? We have what? Dh and dt, dh and dt. So I'm going to write here dh and dt, means these on here, see, dh and dt. I'm going to write here dh and dt. And here we have dr and dt. So r to this side, right? Let's say this is dr and dt. And you see, this is the formula which is the same as this. So this is the formula we're going to use. Okay, now let's start to solve now. So the formula is this, the same thing. So I'm going to raise this, which is that one. So now we look here, right? So we got this one. We know dr dt we have, dh dt we have. So we only have to calculate this one, and you have to calculate this. When you get them, the formula is done, because this equal to 2 and that one equal to 2. So you have to get ds dr and dh ds dh. Now let's go. So now how are we going to get ds dh? Means I have to take the given formula and differentiate with respect to r. So we're going to say given s equal to r squared ds dh means I have to differentiate s, and this side I have to differentiate what? R. So we have a pi r. Okay, so this square root means same as say r square plus h square, and then this is going to be what? Instead of saying square root, I'll say what? Half. Okay, so what I'm going to differentiate, I'm going to differentiate s, because I want to get s and r, and this side I'm going to differentiate only r. So s and r. So we're going to differentiate this implicit function, and let's see how we're going to differentiate the implicit functions. Very, very easy. So now say d t r part of what? Of s, and here it's going to be d t r of everything, r square, and they're going to say what? d t r of pi r square plus h square r half. So now let's go. So on the left hand side, when you differentiate, we're gonna get, when you differentiate s, you're gonna get ds. So this is gonna get ds, and this side is just d dr. Now we go, because only s. Now we come here, when you differentiate r square, it's gonna give us 2r. 2r, but what did you differentiate here? It's like d r over dr, because you differentiate what? R here. When you differentiate r, you get 2r, because these two come back, and then 2 minus 1 equal to 1. This is going to be dr, because you differentiate r over dr, which is cancel. So we don't need that one. I should have just leave it. Now we come this side here. This is a product rule. So the first one must be constant, and then differentiate the second one, and the second one a constant, differentiate the first one. So now, if we leave this as a constant, and now we come and differentiate this one, half is going to go back, and then we're going to drop the way how it is, r square plus h square, half minus 1, negative a half. Now you differentiate what is inside here, but remember differentiate only r, so this is going to give us 2r, and when you differentiate h, it's going to be 0, because we don't differentiate h. Okay, so this, when you write this as a constant, when you differentiate the second one, this will be cut, and then we plus. Now this is going to be constant, and then we differentiate this. So all this stuff now is going to be constant. Let's put it like this. All this stuff now is going to be constant, which is r square plus h square a half para a half. Now when you differentiate pi r, you get only pi. Okay, so now what do you differentiate here is r, so it's like a dr over dr, because look, ddr, so now they can be ddr. Now we go ds dr equal, so this is going to be 2r plus, okay, all this stuff has a negative radius, so it's going to go to the bottom, so this is going to be pi r over 2, and all this stuff has a negative power, so it's going to go to the bottom, so it's going to be square root, because it has a negative half, so square root of x square plus h square, and now to the top is going to be just what? 2r there, 2r, so we add, and this r here is like a pi, okay, and then we have a square root of r square plus h square, and this cancel, so that's what we have on the right hand side. So now this is what we have right now. So since that one we have, so now we say this is dsdr, so dsdr we have already. So now when I get what? And get dsdh. So now we're going to take the same thing, right? So now we want to get dsdh. dsdh is easy, so it's going to be s and h. This one we want to get this one. Okay, so dsdh, you take our formula. So this is the formula here. So when you differentiate, so we say, okay, so we differentiate d dh, we could say d s dh. So d dh of left hand side, what is it? Left hand side of formula we have it, s equal to d dh, because ds over h means, look, this is what I want. So ddh of the right hand side, what the right hand side of the formula is r square plus pi r, and we got r square plus h square, and there we got a half. So now let's go, man, let's do like how we did before. So what we're going to do now, when you differentiate s here, when you differentiate, I'll take everything here, I'll continue. When you differentiate s, it's going to give you ds. And then just over dh here. Now we go to the right hand side. So this is a product rule. We're going to differentiate the first one, and we're going to differentiate the second one. So ddh of r squared equal to 0, because you only differentiate what? Excuse me. You only differentiate what? S and h. So this letter is not s is not h, so it's going to act as a constant, so it's going to be 0. And remember, there's a plus, or you can even separately say look, ddh of r squared. Is r squared has to do with anything with s and h? No, so it's going to become 0. So now we go for a second one. So we plus, excuse me, let me write code here. So ddh of r, so means, you remember the differentiate of ds and h, ds and h. So you only differentiate s and h. Is this s and h or h? No, so it's going to become 0 here in the first group. So we plus here, you say dh of all this stuff. Excuse me, of all the second part, which is like product rule. This is a product rule, so the first one is going to be constant, and then we differentiate the second one. Okay, so ddh, let's go, ddh of r squared plus ddh of the second group. But this second group is a product rule. Means I can differentiate the first one, keep the second one constant, and then vice versa. So ddh of the pi r squared, pi r, and then this is going to be constant, because this is a product rule. Look, this is a product rule. So this constant differentiate this, so differentiate, or put this constant differentiate this. So I started to differentiate the first one, and this is going to be constant, means r square plus h square power a half is constant. Okay, so now we're going to say plus, so that plus, and what's going to happen there? So now what I'm going to do, I'm going to revise it, right? So now this is going to be constant now, means now this is going to be constant, and then differentiate this. So now it's going to be constant now, the r square is going to be differentiated. Okay, so now what we're going to do now, excuse me, remember we differentiate this, we put this constant. Now this is going to be constant now, pi r is going to be constant, but we're going to differentiate the second one. What is the second one? Is r square plus h square power a half. It's easy. So now let's go, man. So this is going to become, so when you differentiate, see, ds dh, so you have your ds dh you're looking for, equal this ds and h. Do you have s or h here? No. So everything is going to become 0. Now we plus here. ddh of pi r squared. So look here, none of these has to do with s or h. So when you differentiate, everything is going to become here 0. So we're going to say 0 times everything here, but 0 times anything equal to 0. So all this group is going to become zeros. So it's going to be 0 is plus bracket 0, and then we plus, then we got that one right there. So it's a pi r, shit, man, do some crap here, baby. So now this is going to be constant, and then when you differentiate, remember we differentiate is ds and h, s and h. So now is this s or h? No. So when you differentiate r, is going to be 0, because your intention is to get, you either differentiate s or h. So this part here is going to be, excuse me, I'm wrong, my apology. You're going to have to take a half back, because you differentiate the whole. This is not separately. So all of this is the one thing with the half. So I'll take a half to the back. So, excuse me. This is constant and differentiate this. So we're going to take a half to the back, a half to the back. And then I'm going to say bracket, and then take this, drop the way how it is, so it's r square plus h square. A half minus 1 equal to negative a half. Now we differentiate what is in here inside. When you differentiate r square, you get 2r. No, remember differentiate s and h, s and h. So when you differentiate the r square, you get 0. S or h, yes, this is h. When you differentiate, you get 2h. Cool. So now you write your bracket. So then this is equal to, this is going to be only 2h, so it's like a 2h here. So 2 and, because this is same as say 2h, so I can just write there 2h, and I don't need 0 anymore, so just say 2h. So it's like a 2 and h, 2 and h here. So 2 and 2 cancel, so I'm going to be left with pi r. So I'm going to be left with pi r, and this, remember, has a power negative, so it's going to go to the bottom because you have to reciprocate. So this all is going to become equal to, okay, so it's going to become okay, this is going to be 0 0, so we're going to be left with pi r, and then all this stuff is going to go to the bottom, so because it has a negative power, it's going to become r square plus h square power positive a half. So I can just square it because positive a half and square root is the same thing, and we still have our h here times h. So this is ds dh. So since this is ds dh, we can substitute ds dh equal to ds dh equal to this now. But I can substitute the value pi r. What is the r? Our r equal to 40, so I can put 40 here. And our h equal to 50, I can put 50 here. And then r again, r equal to 40, I can plug in here. And h equal to 50, I can plug here. And then all of this is going to give me ds dh equal to, plug in all the value, you're going to get 9080.127. This is going to be ds dh. What is the unit of surface area? Millimeter square. For this case, because millimeter square over the h. Height is millimeter. So millimeter and 1 millimeter is cancelled. So it's going to become 9080.127 millimeter, because 1 millimeter cancel. So the same thing we're going to do for here, which is ds over dr. So we have to substitute the value here to get ds dr, because we have to substitute ds dr. So ds dh we have, you're going to substitute here in a formula, and also ds dr, we're going to substitute the value of r here. What the value of r equal to 40, so we're going to put 40 here, and then pi r equal to 4 again, and then 2r equal to 4 again, 2r equal to 40 plus h equal to 50, because you want to get ds dh, and then r square. What is the r equal to 40, we're going to put 40 here, and then h equal to 50, we're going to put the value there, and then plug it in, or we're going to get ds dh equal, so also ds dr equal to 530.988 dr. Excuse me, ds dr, our ds, apologies, ds dr. What is s? S is surface area, so is millimeter over r. R is the radius, which is millimeter for this case, because give me millimeter. 1 millimeter, go. So our ds dr equal to 530.988. So ds dr we have already. The SDH, we have the SDH, which is this one already. dr dt, they were giving us dr dt, which is this one. Okay, and the dh dt, they were giving us 2 millimeters. So what we're going to do, we're going to plug all the value in here in the main formula, which is going to become the SDR we have, which equal to 530.980 times The RDT given. The RDT is 2 millimeter. 2 millimeter. 2. With plus. Now we go. The SDH we have, which is 98.127. 98.127 times, because there's times here. The HDT we got. The HDT was the HDT given 2 millimeter. 2 millimeter. So we're gonna plug all of this, gonna give us the SDT. So what the SDT finally is gonna be, if you plug that out, it's gonna be 1, 2. So DSDT is gonna become 1258.2. But remember, it's DS, so this is surface area, so it's gonna be millimeter over T second. So that's
the more ring for my queen. You gon' wait me till Jesus come. Why when I talk, pocket full floss, money, honey, forget about Suzanne.
So since we don't have all the equipment like, you know, cameras and all this stuff, so just use one of the webcam from my computer. So we're gonna start with these tools and give people knowledge, because that's how they say, you know, start with what you have, and then from there you're gonna elevate it. You know, you're gonna elevate it, and things gonna propagate it, and you know, excuse me, and things gonna improve slowly. You know, because you can't reach down top before start from the bottom. Otherwise, then you're gonna break and start from bottom.